Hey Piedmont, this is Miss Fugate with your daily science video of the day, the Panther way. Now, I teach chemistry, and every time I ask you guys, what do you think of when you think of chemistry, I get the answer elements, chemicals, periodic table, and all that's true. But the one question I get the most often is, when are we going to blow some up? When are we going to blow something up, Miss Fugate? When are we going to blow something up? So I got to thinking with this video, what could I do as a chemistry teacher that would be safe, not explode my house, but something that you would enjoy? And it finally came to mind. Voila! Something you all have been asking me to do for a long time, the Mentos Coke Challenge. So, as any good chemistry teacher would do, I had to do some research to try and figure out exactly what was going on with the Coke and Mentos. And here's what I found. There was a professor at App State in the grand state of North Carolina who, her name was, I had to write it down, Tanya Coffey, and she experimented with this Mentos Coke Challenge several times, of course, and discovered that there were 3 things that affected the Mentos Coke. One had to do with the density of the Mentos. These Mentos are more dense than the Coke, so guess what that means? They sink to the bottom. And by sinking to the bottom, they are surrounded by more Coke, which allows the reaction that takes place to go faster. The second thing that they noted was that these Mentos, when you touch them and look at them underneath the microscope, the coating that's on this Mentos is rather rough. So what does that mean? Why is that important? Well, think of it like this. When you put something in Coke, or any soda, but specifically in Coke, the carbon dioxide that's in that Coke surrounds that substance. Well, the rougher it is, the easier it kind of can attach to and surround. Think of it like this. If you were to go walk outside in your tennis shoes and it were icy outside, you would slip and fall because your shoes wouldn't really grip to that ice. But if you walked outside and it was just snow versus ice, then your shoes would grip to that snow and you wouldn't fall. It's kind of the same idea. If it's slick, the carbon dioxide doesn't have as many places to really, stick to, is kind of the way to word it, as opposed to it being rough. The third, and probably she said the most important aspect that contributed to the Mentos Coke explosion, is the fact that this candy coating, and there is aspartame and potassium benzoate in this, since it's diet versus sugar, which would be in regular. And the combination of the coating and the aspartame and potassium benzoate, they act as a surfactant. Well, Doc Kelly informed us yesterday that surfactants, like his Blue Dawn, breaks surface tension. So while this rough surface kind of attracts a whole lot of carbon dioxide, once it gets there, it decides, you know what, I didn't like you as much as I thought after all, therefore I'm going to get rid of you. So here's what we got to think about. We have all this candy in the bottom, since it's more dense and stuck to the bottom. We have a big buildup of carbon dioxide that's been attracted to that candy, but that carbon dioxide is a gas, and since the candy decided once it got there it didn't like it too good, we got to get rid of it. Well, the only place to get rid of it is to shoot out the top. So, there you go. That's the science behind the Mentos Diet Coke Challenge. Today, let's do it. I'm in my backyard, and hopefully I'm going to get out of the way in time so I don't get covered with this Diet Coke. Are we ready? 3, 2, 1. And there you go. Mentos Diet Coke. It does what they say it's going to do. I hope you enjoyed it as much as I did today. Hope you guys are staying safe and staying well, and we look forward to seeing you soon.